Hi everyone, my name is Saswata, and in this session we'll be learning how to make custom web apps for machine learning and data science in Python using Streamlit. We'll be using the model we built in the previous session using PyTorch, which was trained on the EMNIST dataset. So let's talk a bit about what is Streamlit. It is essentially an open source app framework which helps data scientists build apps for their models. Now, why would you need something like this? Well, it turns out that deploying your own models and building apps so that people can use your models is quite a task. You need to be fluent with web technologies, and even then, you might get stuck if the ML library that you use doesn't work well with JavaScript. You'd need to make your own APIs, your own front end UI, and take care that you don't run into performance issues. With Streamlit, you can completely avoid a lot of these tasks and make beautiful data apps using just Python. No need for a separate language either. Pretty cool, right? So let's switch over to VS Code. So as you can see here, we have the Python notebook which classifies the handwritten letters using the EMNIST dataset. We learned how to do this in the previous session with PyTorch. If you missed out on the last video, I highly suggest checking that out. So let's go ahead and create a new directory named app, and I'm also using a virtual environment to manage my Python dependencies. So we'll be installing a couple of dependencies, namely Streamlit, Streamlit Global Canvas, PyTorch, and Torch Vision. So I'm not going to run this command since I already have the one installed. Alright, so let's make a new file. Let's name the file main.py, and let's import Streamlit as st. And then we're going to show a title on our screen, which is handwritten letters classifier. So this by itself comprises of a fairly basic Streamlit app, and the way you run a Streamlit app is not using Python, but is rather using the command streamlit run app slash main.py. So let's wait for this to run, and this should automatically open in your browser, and we'll see the end result. Takes a bit of time first. So as you can see, it now shows that the Streamlit app is in our browser. So let's switch over, and right now we have a fairly basic Streamlit app with our title, and we also have a menu with a bunch of options, all without any sort of JavaScript, HTML, or CSS. So let's go ahead and add in a few more things to our page. Now we want to set the page icon as well as the page title. So we're going to write in beta set page config, and we're going to set the page title as handwritten letters classifier. We'll also set the page icon as maybe a moon face. So let's go ahead and add that in. So I'll say new moon with face. Moon with face. And this command needs to be at the top of whatever Streamlit app you're writing. Otherwise it sets an error. So let's save that, and let's switch over to a browser and let's refresh. So as you can see, it's compiling, and we have our moon face and handwritten letters classifier as our page title. Now with this app, what we want to do is we want our users to be able to draw a particular letter and ask the model to predict that letter. We also want to show them the probability of each letter as denoted by the predictions in an organized fashion. So right away, what we're going to do is we're going to import our ST canvas, or this is a Streamlit drawable canvas in our application as ST canvas. Notice that I'm writing a lot of as arguments over here so that we can easily refer to them. And the drawable canvas is actually a third-party open source canvas which allows your Streamlit application to let users draw on it and accept that as an image input, which we'll be needing. So okay, So the first thing that we want our users to be able to do is to set the stroke width of the brushes as well as set the drawing mode. So let's go ahead and put a sidebar, and in that sidebar we're going to put a slider which will let users basically set the stroke width. So we'll say stroke width, and we want to let users choose any value between 1 to 100, which will default to 25. And we also want to set the drawing mode. So there are a couple of drawing mode that Streamlit drawable canvas seems to offer. So we want only free draw and transform. Free draw is basically freehand drawing, and transform is being able to select those drawings and move them around. So we'll say drawing tool, and we'll basically give options over here. So let's say free draw and transform. So let's go ahead and save this and sort of refresh. And what we should see is a sidebar where we can set a slider which defaults at 25, but we can set any value between 1 and 100, and we can select our drawing tools as well. And actually we can store these results inside of these variables stroke width and drawing mode. So now what we're going to do is we are going to add in our actual canvas, and we'll be saving the canvas data inside of a variable known as canvas result. So we'll import the st canvas, and over here we're going to set some options. So obviously we're going to set our stroke width to stroke width, and we'll set the drawing mode to whatever the drawing mode the user chooses. Now we also want to set the height and width to around 280 pixels each. So let's go ahead and do that. And we want to set the background color as black. So basically hash 000. So we'll set the background color to hash 000, which is the hex code for black, and we'll set the stroke color to white, which is hash FFF. And we are following this color scheme since it's similar to the one in EMNS dataset. We'll also set a key for this and call it canvas. Okay, so we're done with the canvas thing, but we need to fix the import a little bit. So this will be from, and we'll import that. And we want to show the canvas right after the title. So we'll just cut that and paste it over here. And let's save this. So if we refresh, we should now see our canvas and it will render, and now we can draw on it. We can set the stroke width as much as we want, and be like this. We can even transform, so we can shift our drawings a little bit. So that's our canvas for now. So now what we need to do, so this is basically our UI. We can add a button as well, which will say predict, and so we can add st button and predict. Let's save that. Let's refresh, and we should see our predict button. This actually returns a boolean value. So now we're mostly done with our UI. So let's try to hook in our model, our saved model. So you can see this model.pth file, which is the PyTorch saved model. So let's shift that to our app directory, and we need to basically load this model onto memory and sort of use it. So let's make another file for this, which I'll call torch utils.py. Now with PyTorch, we need to actually import all the libraries that we'll be using, such as import torch. We'll also need the neural network component of torch, so import torch.nn, and I'll just rename this to as nn. We'll also be needing torch vision, since we're working with images. So torch vision.transforms is what we'll need to transform our images to tensors, and for that we'll rename this as capital T, and we'll also be importing the neural network functional component of torch NN. So import functional, and we'll rename this as F. Okay, so now what we need is we need to basically load our model, but we need to define the architecture of our model for that. So let's go on. So we're going to cheat over here a little bit. So let's go over to our Python notebook, and over here we are going to basically copy this class which contains our entire model architecture with all its layers, all the nodes defined till this forward function. So let's copy that and let's paste it over here. I'll just rename this class to emnist, and since we don't have a base class here, we are going to basically be using the nn.module class that PyTorch has to offer. So the tabs are a bit inconsistent here, so let me just fix that. Select the rest of this as it is. Just select that, and I just put a whole tab over there. Let's put a tab here, and we want this forward function inside of our emnist class, so we'll put that. And so this is our class which we'll be able to load into our so we'll load our model. Okay, so now we have the model architecture which we defined as a derived class emnist. Now we need three functions. The first one being transform image function, which converts an image to the same size, a load checkpoint function which loads the pre-trained weights from our model, and a get predictions functions to get the predictions necessary. So we'll use the Torch Vision library to transform a pillow image or a NumPy ND array to a tensor in the transform image function. So let's write that. So transform image. We'll take the image as an argument, and we'll just rename the t.toTensor function as transforms. And what we'll do is we'll just return the tensor. So transforms and then image. Now we need a load checkpoint function which will accept a file path as an argument, will define the model as an object of the emnist class, and use the load state_dict function of nn module to load the state_dict, that is the learned model parameters from device storage. We'll also need to validate the model with model.eval. So let's write that function, def load checkpoint, and we'll accept file path as an argument. Let's declare an object of the emnist class that we just wrote. Okay, and we'll use the model.load state_dict function, and we'll use the torch.load over here, torch.load function, to load the model from the file path, and we'll map the location to a CPU location since it will be in the main memory. And then we'll just evaluate the model and finally return this model. Lastly, third function that we need is the get prediction function, which will essentially just accept the image tensor, unsqueeze the tensor so that it gets transformed to one dimension, and then use the load checkpoint function to load our model and finally return the prediction outputs as a NumPy array. So let's say def get prediction, and we'll accept the image tensor, and we'll just sort of unsqueeze the image tensor using the unsqueeze function that the pillow image offers. So we'll say unsqueeze underscore 0, and now we'll load the model using the load checkpoint function, and we'll just set this as path for now. We'll define path later, and for the outputs, which will be a NumPy array, we'll say model and pass in our unsqueezed image tensor. Okay. And finally, we'll return the outputs, but we need to format this a little bit. So we'll say squeeze, detach, and finally numpy. So with this, we're probably done with our torch utils function, torch utils file. So now, okay, so we straightened out a few typos and added in a path which is app/model.th. So let's return to our main.py and let's import our util functions. So from torch utils, import transform image, get prediction, and we also need the pillow image. So we'll from pillow we'll import image, and we'll keep that as capital I, and we'll keep that as capital I for now. We'll need to import numpy as well, and at last we want to show a bar chart. So for that we need to import pandas so that we can use data frame. So okay, so this one was auto corrected, so let me just erase that image. Cool. So now over here, after the user clicks the predict button, we need to check that the canvas result does indeed have some data for us to predict on, and that the user has clicked the predict button. So we'll also be defining a sort of utility function over here. So let's say def predict, and we'll accept the image tensor as an input over here. So we actually use pillow so to construct our image from that data. So from array, and then since this is a sort of 3D array, so we'll say image, and we'll convert this to our preferred type as well, which is np dot event 8. So np dot event 8. So after we convert that, let's just say let's resize that image. Now our model takes a 28 by 28 image as input so that it is able to predict. So we'll just resize that to 28 comma 28. So after resizing, we want to convert that to a tensor. So we'll use our utility function for that and convert our image to a tensor. And finally, we'll get our prediction from our get prediction function and pass in the tensor over there, and finally return our prediction. Okay, so now what we want to do is we want to keep a check. So if canvas result dot image data is not none, that is the user has drawn something indeed, and result which is true, that means that the user has pushed the predict button, we'll say outputs, and we'll get our predictions from the predict function. We'll pass in the image data as an argument over here, which will get converted, and we'll finally get our predictions. Now with our predictions, we want to show the maximum, the index with the maximum probability, that is the letter that the user has basically drawn. So we'll declare the variable over here, and using an np query, which is np where, we'll say outputs, where output is equal to maximum of the entire outputs array, and we'll just say 0 over here. And finally, we want to show this in our screen, so we'll use the Streamlit library to say stwrite, and with Streamlit you can actually write my markdown on the screen. So I'm going to give a subheading over here saying prediction, and we'll keep a bracket. We actually want to make our prediction in bold, so we'll add stars across it, then format, and finally we want to show our index, but we don't want to show a numerical value. Instead we want to show the letter, so we'll typecast that to a letter, so 97. Since the emnist is a data set which only contains small handwritten letters, so we are using 97. So end max. and this should work. So let's save that file and go over to our browser and refresh. So let's wait for it a little bit. Okay, so now I guess we can draw once this running is over. So let's draw a bee and let's click predict. Yep, our model now predicts and we can see our prediction right on our screen. So with this, you have built a very basic data app. Now, I also want to show all the other probabilities so that we can actually understand how our model is performing when it gives a wrong prediction. So we want to show a bar chart right below this. Okay, so to show a bar chart, we're going to use the pandas data frame type, but for that we need a 2D array and our outputs is actually a 1D array. So we're going to write a function to convert our outputs 1D array into a 2D array, and the way we do that is, let's take outputs as an argument and we're going to actually take the length of outputs. So outputs dot shape, and this will be 0, and then we're going to declare an empty array which will return at the end. So let's write a for loop. So for position in range, and we'll say 0 to length. What we want to do is we want to declare an empty array at first containing all the containing zeros for all the 26 letters of the English alphabet, and we'll say line position is equal to outputs position, and then finally we'll just append that into our main array. So, and finally we'll return that array. Now inside of our if block, which is where we'll show our predictions, and after that we'll show our bar chart, what we want to do is we want to declare a variable chart data which we'll use to show our bar chart, and we'll say pd dot data frame, and pd is how we imported on pandas earlier. So we'll say pd dot data frame, and as an argument we'll pass in our utility function np2df with outputs as that, and then what we want to do is we want to specify the indexes and the columns. So we'll actually need to write all the small letters of the English alphabet. For convenience, I actually stored this inside my readme. So let me just grab that, and we'll declare an array over here, and then we'll also want to do the same for columns. So declare an array, and so we have all the letters of the English alphabet inside of our chart data. So now what we want to do, let's just erase that over there. Okay, and let's just move that bracket up as well. Now what we want to do is we want to actually set a bar chart, which we can do using Streamlit, and inside that we'll pass our chart data. So this should render a pretty beautiful bar chart. So let's go over to our browser and refresh the page. And right now our canvas is empty, so let's give in a input as B, and let's click on predict. So prediction shows up, and now we also get a beautiful bar chart. As you can see, B is the maximum probability, and so now we can actually see how our model is predicting and how it's performing. So with that, you have built out an entire beautiful data web app from a PyTorch model using only a few lines of Python and our trained PyTorch model. So now this is in our local machine, so let's go ahead and deploy this as well. Okay, so what we're going to do is we're going to use Heroku to deploy our Streamlit application. So let's just stop this for now, and we want to commit our changes into our repo as well. I hope you initialized the git repo at the very beginning of this tutorial. So we'll just say git commit minus final changes, and just commit our final changes, and there we go. So I'm just going to explain what these files are. So first we want the proc file, which is just our Heroku deployment file which specifies the type and what commands we need to use to sort of run our application. And as you can see, we have the streamlit run app/main.py. We also have a setup.sh, which is a requirement when deploying a Streamlit application. So you need to make a directory Streamlit, and this will be in the Git repo that is mentioned in the video description. And over here, you need to add in your email ID as well in your credentials.toml, and you need to set a few options such as whether your application will be headless or not, whether there will be cores or not, and what the port of the application will be. And except for that, we also have our runtime.txt, which will specify the Python runtime, and our requirements.txt, which is basically specifying all the requirements that we had, so that Heroku can easily install all the dependencies that are there. And finally, we have a slug ignore file. So what Heroku does is Heroku compresses our application into a final slug, and if it's more than 500 MB, it will throw an error. So instead, we are going to ignore our Python notebook and markdown files for the slug. So I hope you have Heroku installed on your machine, Heroku CLI. So if you don't have Heroku CLI, I'd suggest to go ahead and do that and log in using Heroku login command. Now I already have logged in. So what I'm going to do is create a new Heroku application using Heroku create. So let's go ahead and run that. So as you can see, it created a new application, Mighty Ravine, and now basically what it does is adds a new git remote. So if we do git remote -v, we should be able to see our remotes, and indeed we see the Heroku remote as our fetch and push. So what we're going to do is we're going to push to Heroku. So we'll say git push Heroku master, or rather main, which is our main branch. So let's go ahead and push that. And so this will take some time. Okay, so that took quite a bit of time, but what it did was it downloaded all the dependencies on the Heroku server, and it successfully installed everything. And now it has now our application is actually successfully deployed. So let's go ahead and actually check this out. So, and this application is shut down, so let's close that tab. And you can see that our Streamlit application is running on the server as we speak. And this is my Heroku instance, so let me just actually refresh and check if my new application has shown up. So right over here, a new application has shown up, Mighty Ravine. Okay, so as you can see, you have successfully deployed a Python data application using nothing but Python. You have written no HTML, CSS or JavaScript, but without that, you have successfully deployed an application, and as you can see, we can see the prediction results as well. So thanks for attending this session. If you have any queries, you can reach out to me. My social links are given in the description below. Thanks for watching.